Okay, we're going to go over probability with Venn diagrams, right? They've given us this as an explanation. This one's a little easier to make sense of because it's in words. We're then going to put it in terms of the symbolic language of data management where they talk about the union and the intersection. And then we'll go through the first two questions so it makes sense. So what they talk about is the union. So they use, in their example, it's written like this: the probability of the union of A and B, okay? Which means A or B to us, the probability of A or B happening, which is equal to, the first one stands for all the possibilities of A, okay? Whether it's letters, numbers, probabilities. B, so we add all the possibilities of A plus all the possibilities of B, but from that we subtract when they both exist. This is called the intersection of the both of them. They use the upside down U. In other words, for us, it's when A and B both happen at the same time. So the first question they've given us is they've given us a set. And set 1 contains, what is it? Apples, oranges, and pears, right? So we have our apples, orange, and pear. Okay, we're just going to call them A, O, and P, just to make this a little easier to write out. And set 2 consists of an apple and a banana, correct?
Yeah.
Okay. Apple, which again we'll call A because it's the exact same as the other one, and banana. Okay. The very first question says list the elements of this. So the first question says example 1, they want A and B. Okay? So this is A and B. This is when it intersects for both of them. All right? So we can make a Venn diagram to try to make sense of this. A and B both exist. Well, A and B both exist. We can create two circles here. And we'll look at when they overlap each other. One being bigger than the other. This one, we'll call that the first set. Okay, this is our set 1 and our set 2. Well, in set 2, we have bananas and we have apples. Apples occurs in both of them. And we also have oranges and pears in set 1, right? Okay. So when they ask for A and B, they're looking for when they both exist. Well, they both exist, or when they both intersect each other, that's the intersection or the union of them, is at apple, right? Apple is our answer for what is in both A and B. Okay, well, our answer is apple in that one for a Venn diagram when we set it up, right? The next one is probability of A or B. A or B was our formula over here, okay? That's what this formula is here. It was setting up A or B. And you could always reverse this formula if you needed to. A or B looks like this. So what we're going to do is we're going to take all of the sets of them. Remember, A or B, or in other words, the union of the two of them, is possibilities of A plus possibilities of B minus possibilities of when both happen. Oh, I drew those two upside down. This is union, this is the intersection when they both happen. Okay? This is the union of them. So we're trying to find A or B. That's what this stands for. Okay, well, possibilities of A. Where are all the options of set 1?
Orange, apple, and pear.
Okay, so we have an orange, an apple, and a pear. Okay? And then we're going to add to it possibilities of B, which are what?
Apple and banana.
Apple and a banana. Okay? And then we're going to subtract where do they both intersect?
An apple.
And apple's the only option. Okay? So think of these as like variables, you could say. And we're going to put them all together. So we're going to add O, A, P, A, and B. Well, that gives us essentially O plus P plus B. I'm just going to organize it this way on purpose. Plus A plus A. There's technically two apples here, right? An apple in each. But in the intersection, we actually need to subtract one apple because they both have that option. So if you're going to think of it mathematically, you know, maybe there's a coefficient of 1 in front of each of these. One of these apples essentially cancels out the other, okay? Or creates a 0, you could say. So when they cancel out the other, what we're left with is an orange, a pear, a banana, and just one apple. And that's the possibility of A or B, okay? because we took away the possibility of when they both happen. They both have apples, so we don't add an extra apple to it in this question. Okay? So that's how we're kind of set up that equation with our Venn diagram. And then finally, the last one they ask us is the set. Well, the set essentially means everything. Okay? Was it the second? That was the second one. This is our third example. The third example, they want the set of all the numbers. Well, we'll zoom in one more time. What they mean by that is, what are all the possibilities in here? Well, the possibilities in here, we have a banana, we have an apple, an orange, and a pear, which ends up being essentially the same thing, right? They've written it as S. S is all of the options. So banana, apple, pear, and orange. Okay? That's what the set of them consists of, everything within those two sets. Okay? Okay. So we just did that question about the Venn diagram, or in other words, union and intersection of something. We're going to reverse that because they gave us a formula for the union, right? Our union being the probability, and let's just go to one page so it's a little smoother. Our union being A, U, B is possibility of the value or the part probability of all of A and B, subtract when they both happen, or in other words known as the intersection. Okay? This is the formula they gave us. We can rearrange this formula. In fact, what I'm going to do is I'm going to give them letters to algebraically rearrange this, okay? Just so we can do that. So I'm going to call this set here, I'm just going to call this X, okay? Possibilities of A, we'll just call A. Possibilities of B, we're just going to call B. And then we're going to subtract, well, the intersection of them we'll call Y, just so it's a little easier to work with. Well, let's say we wanted a formula for the intersection. In other words, remember these words, or union stands for or, and intersection stands for the word and. Well, what if I wanted to have a formula for that part? In other words, I want the Y by itself, right? So let's rearrange this formula. If I move A and B to the other side, what do they become?
Minus
Yeah.
A minus.
Yeah. Negative A, negative B is equal to still negative Y. How do I make Y positive?
Bring it over to the other side.
Okay, but then I've isolated Y. Y is almost isolated. The last thing I want to do is just make it a positive Y. I'm just going to draw arrows in the meantime. Think about it for a sec. I could multiply both sides of the equation by something.
Multiply both by negative.
Perfect. Yeah. Let's multiply both of it by -1, right? So when I do that, my new formula, we'll write it in blue, is going to read, go away, Y is equal to positive A, right, plus positive B, and I'm just going to rearrange it minus X. And the reason I'm going to rearrange it, okay, and in fact what I'm going to do is I'm going to move the Y to the other side. Okay. This is still the exact same equation. We've just rearranged it a little. Y is equal to A plus B minus X. Well, we wrote our letters in, so let's actually write in what that means. Let's try to make sense of that. What they're saying to us is that Y, which stood for the intersection of A and B, okay, remember that's and, is equal to possibilities of A plus possibilities of B, subtract the union of A and B, in other words, or. Now, the reason they don't tend to write the formula this way is because it's a lot easier to visualize and, oh, what do they both have, than what A or B. Okay, we're talking about A or B here. Now, we know from the previous question when we were talking about oranges, pears, bananas, remember it was written in the other one, and we'll quickly make another Venn diagram to make sense of this. Our options were set 1 and set 2. One of them had a banana and an apple, and the other one had an apple, so they both had apple. That's where the and comes in, right? And the other option was pear and orange, right?
Yeah.
Okay. Well, we already knew when we were looking for the union of them, when we put these all together, our options, we figured out that you could get a banana, a pear, an orange, or an apple for the union of the two. Okay? Well, what do they both have? We can visualize looking at this, they both have A. Let's write it out algebraically. Let's try to actually solve it. Okay? So what are our possibilities of A and B? Well, possibilities of A, this is our set 1, which are our A's, right? And this is our B's, which is set 2. Well, set A had a pear, an orange, and an apple. And set B, okay, these are possibilities of A. We're looking for the intersection of A and B. So we've reversed the formula a little, okay? So A and B. Plus possibilities of B, which are banana and apple. That's our possibility of B. Subtract the OR. Now, it's kind of hard to visualize the OR, but because we've already got the previous answer, we know what we can write here. Do you remember what the answer was for OR? Or the union of them?
There's P-O-B.
P-O-B. Was there anything else left on that page? Let's go back and double check. Yes, there was an A involved too. And just to make that clear, we'll go back to the other page. Yeah, do you remember we got O, and we'll kind of underline it, P, B, A. Okay? So I know I can use those to subtract on our other page here. Let's go back to single page. Okay? And there's also an A. Well, let's think about this kind of algebraically as if we were eliminating things. Well, if we were to eliminate things, because these are negatives, these P's, we're subtracting a P. We have to subtract an O. We have to subtract a B. And because in OR, we need to subtract an A. I can choose either one. So what am I left with in terms of and? A, which makes perfect sense to us because we can logically look at the intersection of A and B, or where A and B both happen, A standing for apples. That's what we got for our answer, right? We know there's only one left. So that formula can be reversed. The only reason they usually write it as the union is because it's hard to visualize the OR, where it's very easy to visualize the A, and that's why they use the first formula. The first formula they use more often because it's easy to visualize what has both rather than what is OR. Okay, does that kind of make sense? So we can algebraically solve both of them with those formulas. It doesn't matter which one we use.